Hey guys, am I audible? Hi guys, hello, how are you all? Less attendance guys, why? Today we are doing Menti, come on everyone, tell your friends quickly. Call them, ask them that there is Menti quiz going on today again. Maza aane wala hai, yes. Come on guys, go to your WhatsApps, share the link with them for the session and let's go ahead. So guys, welcome back to Vedantu's JEE channel. For all the people who are targeting JEE 2021, that means people who are moving from 11th standard to 12th standard. Yes, quickly, before I start, just go on menti.com, use the code 309507. Quickly guys, quickly. All your friends. Namaste everyone. Welcome once again for the Gauss Law Menti Quiz. Don't worry, I'm not just starting right now. I know a lot of students are here for the first time. Great. So for those who do not know me yet, जो लोग पहली बार सेशन में आए हैं, so guys, let me start with my introduction. As always, this is me, your Suri Sir. I'm also known as Mogambo on this channel. Why? Because when you will crack this examination of JEE next year, Mogambo khush hoga. Okay? And you know that today is Monday at 8 p.m. every day at, sorry, not every day. On Monday, Wednesday, and Thursday, we meet for MCQ discussions, sometimes on Menti also. And at 9 p.m. every day, we meet for theory. Who are your teachers? This is Harsh Sir. He is your go-to chemistry person. This is Arvind Sir, and Arvind Sir is your maths guru. And yes, this is me, the poor fellow. I try to guide you for physics. Okay, guys. And if you are new to the channel, only thing that I would want you people to remember is the timing, most importantly, that 8 p.m. on Monday, Wednesday, and Thursday, we meet for MCQ discussion like today. And if I speak about today's 9 p.m. session, you can see that Monday you will have her session at 9 p.m. which happens every day here. Okay, and if you are new to the channel and you are not aware about this, then guys, Vedantu has its JEE 2021 specifically a program running for guys who are moving to 12th standard. Okay, it's basically on Vedantu's platform, for which all you have to do is go on without any fees. It's a free of cost enrollment for all of you guys with all these amazing features over there. Okay, people, do take the advantage of it. And if you are new to the channel guys, अगर चैनल पे पहली बार आए हो या आप पहले से रहे हो लेकिन अभी तक सब्सक्राइब नहीं किया है, तो क्विकली सब्सक्राइब and press the bell icon as well, because you don't want to miss out on the information, or whenever I will come live you will see me, you will get the notification. Okay, नहीं अभी तक क्लास स्टार्ट नहीं हुई है, क्लास स्टार्ट होने वाली है, because अब हम लोग स्टार्ट करने जा रहे हैं गॉस लॉ मेंटी क्विज. ओके, सो दिस इज द मेंटी क्विज. ओके, नहीं यार, I did not eat anything yet. Guys, quickly, for all those who are joining us now, go to menti.com. Go to www.menti.com right now. Okay, and use the code. This code is what I want you people to use. That is 309507. Okay, cool guys. I hope you are aware now. See the setup once again. I am seeing that the video is buffering at your end. Okay, now I can see the live feed for myself also. That's good, guys. That's good. Okay, so quick, let's go, guys. Just refresh once and let's start the quiz. And this is our very first question, everyone. Okay, haven't started the quiz only. Let's start the quiz. Okay, cool. So electric flux through a surface. Electric flux through a surface. You have to answer, is the amount of electric field piercing the surface? Is the electric field multiplied by the area? Or it does not depend upon the area involved? Or it is the line integral of the electrical field around the edge of the surface? What do you think is the correct answer for this? Come on, guys. So I have response from 74, 75 people now. Come on, guys, quickly. Don't respond in the chat box. Go on menti.com and respond there. Okay. So, guys, last 5 seconds now, and it is the time for quickly. Yes. Okay. Majority people got it wrong, and only 30 people got this right. So, if we look at the leaderboard here, I can see. Okay, Sparsh, Gauss, Full Masti, Full Maza, Akash, Nikhil, Silky, Santosh, Path, Jugraj, and Honey. Very nice. So, guys, not a difficult one. You know that electric flux is nothing but the number of field lines which are crossing a given surface, and that's how we define the electric flux. So, जितने number of field lines enter होके बाहर निकल जाएंगे, that's basically what defines the flux here. Okay, cool. Let's move on to the next one, guys. Are you all ready? Guys, next question. The area vector for a flat surface. The area vector for a flat surface, according to you, what do you think is the correct answer here? It is parallel to the surface and has a magnitude equal to the length of the plane. It is perpendicular to the surface and has a magnitude equal to the length. It is parallel to the surface and has a magnitude equal to the area of the surface, and is perpendicular to the surface and has a magnitude equal to the area. Which of the options you guys think is the correct answer here? What is area vector according to you? Last 10 seconds now. Come on, guys. Come on, quickly. Do not respond on the chat box. No point, because you will not get any points there. Okay? Awesome. Yep, area vector is something which is option D, perpendicular to the area of the plane, perpendicular to the surface of the plane. Okay, just a minute. Okay, let me show you the explanation part also. So the area vector answer is option D. If this is basically your surface, then area vector is going to be an area or a vector which is perpendicular to the surface here, and its magnitude is going to be equal to the area of the surface. Like magnitude of A is going to be L into B for the rectangle that you see here. Okay, guys. Okay, blank. The IIT Bombay versus IIT Roorkee session has been recorded yesterday successfully by me and Arvind sir. Will be put on the channel by tomorrow or maximum by day after tomorrow for sure. Okay, editing is going on. Cool. Okay, next one for all of you guys. Next question. Quick, everyone. Let's participate. Maximum flux through a piece of paper placed in uniform electric field is 25 Newton meter square per coulomb. What is the flux when it is turned 60 degree with respect to field? So already the flux is given. When area vector and electric field are along the same direction, you have to tell the flux when it is turned 60 degree with respect to electric field. Come on guys, half time is over. Quick everyone, quick. Flux is dot product of electric field and area vector. Okay, last 15 seconds running. In fact, now the last 10 seconds. Quickly guys, quickly. Last 3 seconds now. Okay, time's up. And I'm glad that majority people got this answer right. Yes, the answer is 12.5 Newton meter square per coulomb. So guys, what is given to us already, that flux 1, which is E into A, it is given to us as 25 units. Okay, 25 is given. Now what has happened, the area vector and electric field vector has now been inclined at 60 degree. So the flux will become EA cos 60. E into A is 25 and cos 60 is half. So the answer is going to be 12.5 Newton meter square per coulomb. Okay, cool. Leaderboard will come after some time, don't worry. Okay, here's your next question, everyone. Next question is, in a region of space, the electric field is given as 8 I cap plus 4 j cap minus 3 k cap. The electric flux through a surface of area 100 units over is going to be how much? Okay, time's up guys, time's up. So guys, the correct answer to this question is, okay, this part was missing, XY plane was not mentioned. So no problem guys, learning is more important, always remember that. So basically, if the area is placed in XY plane, then the area vector is going to be along k cap. That means 100 k cap is your area vector. So if your electric field vector is 8 I cap plus 4 j cap plus 3 k cap, then area vector is 100 k cap. So the dot product of E and A will only be equal to 3 into 100, and that will come out to be 300 units. Okay guys? Okay. So guys, the leaderboard so far, let's see who is leading here. We have Gauss who is leading the leaderboard here. Very good. Gauss, Parth, Augie is here. Where are the cockroaches? Blank, Ruchir, Hare Krishna, Boss, Parth and Lokesh and Krishnam are there. Very good guys, very good. Let's go to the next one quickly. Next question is, if you guys are joining us right now, go to the Menti Quiz, menti.com, use the code which is written here. Next question, Gauss law applies to lines, flat surfaces, sphere only or closed surfaces. Which of these you understand is going to be the application of Gauss's law? Come on everyone. Last 3 seconds guys, come on. Okay, time's up. Very nice. I'm glad that people know this. So guys, to this the answer is closed surfaces. Again, a trivial question. This is something that you should know, that Gauss's law will only be applied for closed envelope. Gauss's law will only work when you are dealing with a closed envelope, like a point charge placed in a sphere, in a cube, in a cylinder, any three-dimensional envelope, the charge has to be inside. So that 3D envelope is basically your Gaussian surface or closed surface. Okay, cool guys. Let's move on. Again, let's go back to the Menti quiz. The next question for all of you guys. Join quickly. And the question is starting here. total flux across a surface enclosing charge is independent of? Come on everyone. What do you think? Total flux across a closed surface enclosing charge is independent of what? Is it independent of the shape, volume, actual spatial arrangement of the charge, or all of the above? What is it independent of, total flux? Okay, approaching last 5 seconds now. Come on everyone. And the time is up. Yes, the answer is option D, and I'm glad that majority people are now responding correctly. So guys, the correct answer for this question is option D. Your total flux does not depend upon the shape of the closed surface. That means if your charge is enclosed in a box or it is enclosed in a sphere, does not matter. The flux is going to be Q by epsilon naught only. So it does not depend on the volume, also does not depend upon the arrangement of the charge. That means you can place the charge anywhere, but it has to be enclosed. It does not matter where exactly you are keeping the charge. Okay, cool, awesome. Next one, everyone. Next question is on the screen for all of you. The total electric flux through a closed surface depends on what? So it's the counter question of the previous one. Tell me quickly. There is only one Gauss's law, Sarthak. Tell me guys, what do you think the total flux through a closed surface depend on? It depends on the location of the charge, on the shape of the closed surface, on the value of the net charge only, or both the location and the charge and the shape? What do you think guys? What does electric flux according to you depend on? Last 10 seconds running, everyone. Come on. Okay, time's up, everyone. Time's up. Good. Correct answer is option C. You know that the total flux that we calculate, I just now told you people that it depends only on the enclosed charge value, Q in by epsilon naught. It does not depend upon the shape of the surface. It does not depend upon the location of the charge inside. It actually depends upon the total net charge present in the Gaussian surface. Okay, cool. Next one. Okay, before that, leaderboard quickly. Let's have a look at the leaderboard, everyone. So here I see Gauss is leading. Okay, Gauss, no more leading. It's Parth, Blank, Hare Krishna, Gauss. Now you are there. Very good, Parth. Congratulations. Keep it up. Keep it up, guys. Okay, next question, everyone. If the flux of the electric field through a closed surface is zero, then if the flux through the closed surface for an electric field is zero, then what do you think is going to be correct? The electric field must be zero. The total charge inside the surface must be zero. The electric field must be uniform, and the charge outside the surface must be zero. What do you think is going to be the correct answer? Very good, Blank. You are on the second place. Come on, guys. Respond on Menti. Last 10 seconds. Okay. It's coming to an end now. Very nice. Majority people got this answer right again. Very good, guys. Answer is option B. That if the flux of electric field has to become zero, then that is only possible when the charge becomes zero. Again and again, the Gauss's law, which is E dot dl, if this value, E dot dA in fact, if this value which we say is Q in by epsilon naught is becoming zero, then it's not just electric field, it's basically the net charge inside the surface which will have to be zero in order to make the value of flux to be zero. Okay, cool. Okay, the next one. Okay, before that, quickly, you have your leaderboard once again. We have Parth still leading, Hare Krishna coming up, and Gauss on the third position. Silky, Augie, Thani, Heartstorm, DIP Roy, Blank, and Boss. Congratulations, guys. Congratulations. Keep it up. Okay, let's move on to the next question now. Keep it up, guys. Next question, everyone. Have a look at the screen, everyone, quickly. Gauss's law is useful for calculating electric field which are symmetric, which are uniform, which are due to point charge or due to continuous charges. What do you think Gauss's law is used to calculate? Which type of electric field will be calculated? Okay, Nishit, next time onwards, please keep your real name. It's difficult to remember the names. Okay. Come on, guys, last 5 seconds for all of you. Time's up, guys, time's up. Okay. Looks like a lot of confusion here. So it's a trivial one for all of you again. The correct answer is Gauss law will be able to find out only the symmetric arrangement of electric field lines that you will be able to find out. Non-symmetric arrangement of electric fields will not be able to find out. Not that only uniform, but you can find out non-uniform electric fields also. You found the value of kq by r square, which is not uniform, by the way, but the electric field was symmetric for a point charge also. Okay, guys, quick and simple. So moving on to the next one. Look at the screens, everyone. Question for all of you. A Gaussian sphere closes an electric dipole within it. Then the total flux through the sphere is. What do you think is going to be the correct answer for this one, everyone? Last 30 seconds now. Last 15 seconds. Come on, guys. Last 3 seconds, everyone. And time's up. Let's see who got it right. How many people got it right, in fact. So, very good, yeah, very good. A Gaussian sphere is having a dipole inside. So, definitely, if a dipole is placed inside, you know that there will be effectively no charge inside the Gaussian surface. If this is plus q, this is minus q. Q enclosed is basically equal to 0, and I'm really happy that you all, majority people, got this right. Answer is option C. Very good, guys. Keep it up. Next one. Next one. Quickly, guys. The total flux through the below spherical surface is going to be how much? What do you think is going to be the net flux through this surface? What you see here is basically a surface. Through this surface, what do you think is going to be the net flux? Is it positive, negative, 0, or not well defined? Come on, everyone. Last 15 seconds to respond for this one. Okay, last 5 seconds. And countdown has begun. Let's see if you got it. Cool. Still a disparity in a lot of cases here. I was expecting everybody to be able to get this right. Answer is 0, guys. Come on. You can see that the amount of flux which is coming inside, all the field lines which are coming inside, they are all coming out as well. That means the net incoming flux is equal to outgoing flux. So the total flux inside is 0 and there is no charge inside. Q enclosed is 0. If Q enclosed is 0, then the flux has to be 0. So that's why the answer is option C. Okay. Let's see the leaderboard quickly. Who all are leading right now? Okay, I see Parth again. He is maintaining his position. Hare Krishna, Gauss, Augie was the fastest for this one. Very good, Augie. Harsh, Hari, Honey, Dip, Boss, and Shrinjoy. Very good, guys. Very good. Keep it up. Next one for all of you. Have a look at the question, guys. Everyone. The electric flux from a cube of edge L is phi. If the edge of the cube is made double and the charge enclosed is halved, its value will become how much? How much will be the flux after the size of the cube has been increased and the charge has been decreased? What will happen here? What do you think, guys? Come on, everyone. Last 10 seconds running. Time's up. Time's up. Okay, I can see 44 people got this right. So guys, it was not actually difficult. This will have no impact. Means even if the size of the cuboid is doubled, it will not change the outgoing flux. It has nothing to do with it. What it depends on, you know that flux depends on Q in by epsilon naught. So if earlier it was Q by epsilon naught, phi dash will be Q by 2 by epsilon naught, which is half of previous flux. Okay, I hope you guys are getting it. And now the time for the next question. Come on, guys. Have a look at the question. The Gaussian surface for a point charge will be, what do you think the Gaussian surface for a point charge is? A cube, a cylinder, a sphere, or cuboid? What would you choose as the Gaussian surface to calculate the electric field, obviously? To calculate the electric field, what do you think you will choose as the Gaussian surface for a point charge? Come on, guys, quickly. Respond. Tell me, what do you think is the Gaussian surface for a point charge? And last 5 seconds. Okay. Time's up. Time's up. Very good. It's good that most of the people are aware about it. For a point charge, the Gaussian surface that we choose is basically a sphere, because here if I choose any point where I'm interested in finding the electric field vector and the area vector, they are inclined at 0 degree. So that is why it is easier to find out the value of the electric field. Okay, awesome. Now this one for all of you guys. Gaussian surface for a line charge will be what? Tell me. If you got the previous one, you should get this one as well. What do you think is the Gaussian surface for a linear charged object? Okay. Last 10 seconds now. Okay. Time's up, guys. Time's up. Yes, correct answer is option B, that is cylinder. You know that for a thread which has charge, the Gaussian surface that we will choose is going to be a cylindrical surface with electric field lines coming out like this in the radial direction. Okay, again a trivial question. I am sure you guys are aware about it. Okay, this one, guys. Before that, the leaderboard. Let's see. Very good. So I can see this time Parth has been left behind by Hare Krishna, then Augie, and then Parth is there. Harsh, Hari, Boss, Thani, DIP, Shrinjoy, and Pooja are there. Very good, guys. Very good. Let's have a look at the next question quickly. So guys, electric field lines due to an infinite sheet of charge is going to be what? It's going to be converging, radial, uniform, or perpendicular to the sheet, or parallel to the sheet. Think about it, guys, and tell me. Come on, guys, last 15 seconds. Okay, everyone, time's up. Very good. Majority people got this right again. Yes, for an infinitely long sheet, the electric field lines are going to be parallel, and they are going to be perpendicular to the sheet itself, and they are going to be parallel to each other. And that's what the uniform electric field is going to be. In fact, in the next question, something which is again related to the previous question itself. Tell me, the electric field intensity due to an infinite plane sheet of charge is going to be how much? It is related to the previous question only. Is it sigma upon epsilon naught, or sigma q upon 2 epsilon naught, or sigma upon 2 epsilon naught, or q by epsilon naught? What do you think is the electric field intensity due to an infinite plane sheet of charge? Last 5 seconds, guys. Come on. Okay, time's up, time's up. Cool, good to know that. Yes, the answer to this electric field value is sigma upon 2 epsilon naught. In fact, in the previous class only, in the theory class, we did the derivation for the same. Okay, so no point in getting into the derivation once again. You can watch the video if you were not in the class previously. You can watch it, all the derivations were done there. Okay, cool, everyone. Next question. Charge Q is distributed uniformly throughout a spherical insulating shell. The net electric flux through the inner surface of the shell is how much? So if the charge is distributed on a spherical insulating shell, hollow sphere it is, so the net electric flux through the inner sphere of the shell is going to be how much? What do you think is going to be the value of the flux, guys? It all depends upon the charge enclosed inside the inner surface. Last 5 seconds, everyone. Come on. Okay, time is up. Time is up. Let's see. Very good. Very good. I can see people are improving. Yes, guys, correct answer is 0. Is because the enclosed charge is 0. All the charge is residing only on the outer surface. That's why the flux is going to be 0 through the inner surface. Okay, guys. Okay. The leaderboard. Let's see who's keeping the lead now. Looks like Augie is going to take the lead. Yeah, Augie, very good. Augie, Hare Krishna, Parth, and Harsh are on the top as of now. Cool, guys. Let's see this one. If you can get this. A point particle with charge q is placed inside a cube at its center. The electric flux through any face of the cube will be how much? Tell me, guys. A point particle is placed inside the cube. The flux through one of the surfaces of the cube is going to be how much? 0, q by 2 epsilon naught, q by 4 epsilon naught, or q by 6 epsilon naught. Abhi or anyone who wants to join, it's menti.com, where you have to go and use the code 3095 and 07. This is basically the information that you are seeking here to come for the Menti Quiz. Okay. Harish Parbat, IIT Bombay versus IIT Roorkee. That session was recorded yesterday, could not go live. That session will be put by tomorrow or day after maximum. The editing is going on. Okay. Come on, guys. Last 3 seconds now. Okay. This was an easy one though. It's not difficult. Yes, the correct answer is option D. So guys, if you have a cube, then how many surfaces the cube has? So the number of surfaces are basically 6. So if I say that through each surface, if the flux is going to be phi dash, then phi dash is going to be 6 times the total flux, or in fact the total flux is going to be total flux, which is basically Q by epsilon naught. It is going to be 6 times the flux through each surface. So phi dash is basically Q by 6 epsilon naught. 1/6 of the flux will go through one of the surfaces. Okay guys, awesome. Let's have a look at the leaderboard. Very nice. Augie is maintaining the position. Come on guys, let's have a look at the next question. So a point charge sits at the back corner of a cube. Find the electric flux through the face of the cube shown below. So now your charge is placed at the corner of the cube. So you have to find out the flux through the single surface again. So try to visualize this properly guys. This is something which I told you people in the previous class also. I'm sure if you have understood that question there, you will understand this one also. Come on guys, last 30 seconds running. Last 20 seconds now. Come on everyone. Okay, we are in the last 10 seconds now. Okay guys, time's up, time's up. Entire spectrum. Guys, the correct answer is option D, and it's an interesting one. Have a look at this. So this is your question and this is the surface you actually are looking to find out the value of the flux for. But that charge can be assumed to be actually at the corner of this big cube, whose single cube that you are interested in is this one. This is the cube that we are interested in. Okay, and this is the surface through which we want to find out the flux. So if we look at this entire surface, say A, B, C and D, so flux through A, B, C, D is already found in the previous question, that is Q by 6 epsilon naught, and now you are also dividing it into 4 parts. So 1/4 of that is basically what you are looking for. Let's call it P, Q and R. So flux through A, P, Q, R is basically 1/4 of that value, that is Q by 6 epsilon naught. So total answer is Q by 24 epsilon naught. Okay guys, I'm sure you guys understood it, and let's have a look at the leaderboard. Very nice, very nice. So Augie finally wins today's Menti Quiz competition. Very good Augie, congratulations. Very well done guys, very well. So guys, if you are a student who's preparing for JEE 2020, you know that your examination is happening in the month of July between 18th to 23rd of July. And for your preparation, there is a crash course batch which has already begun on 11th of May, where you are getting 90 live classes, you are getting a lot of tests, you are getting the analysis of your performance, you are getting rank booster quizzes, and a lot many more things guys. Okay, so if you want, you can join the crash course. You can join the crash course. For that, all you have to do is go on a link that I'm going to show you very soon and use this coupon code SMCC, because the course worth rupees almost 25,000 can be yours for just under 6,000. These are the steps that you have to follow. Okay, let me show you how it is to be done. So guys, all you have to do is go on this link. You see this link guys, this is the description that we are on right now. and over here all you have to do is find this third one where you have the crash course. Click over here. If you click here, you'll be directed to this where you have to click on buy now. When you will click on buy now, you will be directed to this page, and here is where you will be putting the coupon code, and once you will put the coupon code, your fees will become 5,999. Okay guys, let me show you how exactly this looks also. So guys, this is basically how the Vedantu platform will look to you. You can see that in your calendar, if you are looking for somebody to actually give you a routine, forced routine, so your timetable is here. So see, if today, that is 18th of May, you can see that at 4 o'clock you guys had a lecture from Aditya Sir on quadratic equation. Similarly at 6:30 also you had your lecture for Center of Mass, Momentum and Impulse, that is physics, by Guru Prasad Sir. So like that your entire timetable is there. Okay, you don't have to, get into the stress and pain of making the timetable. You just have to follow it. Your time is very precious. Okay, in fact, let me show you what exactly and what else is helpful for you here. Okay, so you can see that your content, you can see the content as well over here. Let me show you something which is very, very, very amazingly helpful for most of the students. So in the content library, if you are going for the crash course, say in the physics itself, see, as your course progresses, you get the assignments and notes for different chapter here. See this? If you click on this assignment, go on attempt, you will see that it's like a test that you can appear for. So when you go and appear for this test, guys, see, this is exactly the way your JEE examination screen will look like. So it's an amazing way of practicing. You can click, you can deselect, you can click, you can save and go to next. Like that you can appear for a 30 question mock test for yourself. Okay, not just that guys, you can see that there are assignments and notes also available for you. So if you click here, see, the notes are there for you in terms of theory as well as problems. These are all previous year questions which you can see here. Previous year JEE questions are there for you to practice. So all these things is basically what you are getting in your crash course over here. All you have to do guys, go in the description, click on enroll now. You have a coupon code, use the coupon code, that is SMCC, and then enroll now. Okay guys, I hope you have understood. Also, if you want to miss on the lectures which are done before this for students who are from 2021, this is the information for you all. If you missed the previous lecture of electrostatics, how can you cover up? Guys, this is how you can cover up. Go on the playlist, and in the playlist you have to look for JEEt Law 2021. You will find the playlist itself. Okay. Also, Telegram group, you can join the Telegram group of Vedantu by again going to the description box. It's available there. Okay. So guys, I hope you enjoyed the Menti quiz today. If you did, then press the like button over there. Tell your friends that Menti quiz has started on our channel by Suri Sir also. And if you have not, then do subscribe to the channel also with pressing the bell icon right away, so that every time when I come live, you are notified. Okay guys, so I'll see you again with more theories and more Menti quizzes. Till then, keep studying, keep enjoying. More importantly, stay safe inside your houses. Bye bye guys, take care.